we have w squared plus 8w plus 20. And what we notice right from the start is that we cannot apply normal trinomial factoring. So we would need to use another method. And we are going to use completing the square. So if I rewrite that expression, I have w squared plus 8w. And then to complete the square, I focus on the coefficient in front of w. So I'll add half of that coefficient squared, and I'll subtract half of that coefficient squared. So I add and subtract half of the coefficient of w, which is 8 squared. So it's plus 4 squared minus 4 squared. Now what I've created is a perfect or complete square in my first three terms. So I can apply normal factoring, which would be w plus 4 times w plus 4. That product would lead to w squared plus 8w plus 4 squared. And then I can bring down the negative 16 of the 4 squared plus 20. So if I rewrite that slightly, I have w plus 4 in brackets squared plus 4. And again, we notice that we cannot factor further, because this is not a difference of two squares. But with our understanding of complex numbers, we can rewrite the plus 4 as negative 2i squared. So we have w plus 4 squared minus 2i squared. This now is a difference of two squares which we can easily factorize. So when I factorize, I have w plus 4 minus 2i times w plus 4 plus 2i. And that is how we can factor this trinomial. So first we completed the square to create a complete square or perfect square that we can factorize. And then from there, we rewritten plus 4 to be negative 2i squared, which led to a difference of two squares which we could easily factorize.